Okay, so we're diving deep into deep clustering today,
Mm-hmm.
and you're specifically looking for ways to improve your results.
Yeah.
You sent over this pretty intriguing research paper,
Yeah.
Rethinking Deep Clustering Paradigms. Self-supervision is all you need.
All right.
And I'll be honest, this one's a bit on the technical side.
Sure.
Luckily, we have expert speaker here to break it all down for us.
Happy to help. I think it's a paper that really shakes things up in the field.
So you're probably already familiar with clustering, right? Essentially grouping similar things together.
Right.
But traditional clustering methods struggle when faced with more complex data like images.
Yeah.
That's where deep clustering steps in using AI to uncover those hidden patterns,
Uh-huh.
especially in massive data sets.
You can think of it like trying to find constellations in a sky full of stars.
Okay?
Deep clustering can help you connect the dots and see those patterns you might otherwise miss.
So this paper, though, argues that the standard approach to deep clustering, the one that relies on those pseudo labels, might be doing more harm than good.
Hmm.
I'm curious, what's your take on that?
Well, the researchers have found that using these pseudo labels, which are basically the AI's best guess about which data points belong together, can actually distort its understanding of the data. It's like trying to solve a puzzle where some of the pieces are in the wrong place.
I see.
You might think you're getting closer to the solution,
Right.
but you're actually creating more confusion.
So these inaccurate guesses throw the AI off track, but how does that actually play out?
There are a few ways this can happen. For example, the researchers found that relying on pseudo-labels can lead to something called feature drift.
Okay.
Imagine you're trying to navigate using a compass that keeps changing directions.
Uh-huh.
You'd end up completely lost.
Oh, that makes total sense.
Yeah.
It's like the AI is trying to learn from the data, but these unreliable pseudo labels are constantly pulling it in the wrong direction.
Exactly, and the paper proposes a pretty radical solution.
Okay.
What if we ditch those misleading pseudo-labels altogether?
Oh, okay. That is radical, so no more educated guesses. What do they suggest we do instead?
They suggest focusing on something called proximity, which is all about understanding how close data points are to each other in the AI's internal map.
So instead of trying to label or categorize the data, we're just letting the AI figure out the relationship.
That's the idea.
Okay.
The paper introduces a method called RDC, which stands for Rethinking Deep Clustering. It still uses a two-step process, but with a key difference.
Right.
The first step is all about letting the AI get a feel for the data. Think of it like giving the AI a blank canvas and letting it sketch out the basic outlines of the landscape.
And then in the second step, this is where the proximity focus comes in.
Precisely. Instead of using those potentially misleading pseudo-labels, the AI is trained to focus on the relationships between neighboring data points.
So the AI is looking for those points that are consistently close to each other.
Yes, and it uses a pretty sophisticated method to find the most reliable neighbors for each data point. They're not just looking for the closest points, but for points that have a consistent distance pattern.
So it's not just about proximity, but about the consistency of that proximity.
Yeah.
Like if 3 points are all close to each other and all about the same distance from some central landmark, that's a pretty strong indicator they belong together.
You got it. And then instead of trying to reconstruct individual data points, the AI focuses on reconstructing the centroid of those reliable neighbor groups.
Centroid? Now you're getting a bit technical on me.
Think of it like understanding the vibe of a neighborhood rather than the specific features of each house. The centroid represents the average location of all those reliable neighbors.
So the AI is learning to cluster by understanding the center of gravity of these reliable groups.
That's a great way to put it. And by focusing on these centroids, the AI can learn to represent the data in a way that naturally clusters similar things together.
Okay, I think I'm starting to get this. It seems like a much more intuitive way for the AI to learn about the data, but does it actually work better in practice? We've established that this RDC method sounds pretty promising in theory, but you know what they say, the proof is in the pudding. Did the researchers actually put this to the test?
Absolutely. They conducted a series of experiments to see how RDC stacked up against other deep clustering methods.
And what were the results?
Well, they tested RDC on 6 different datasets, including image datasets like CIFAR-10 and Fashion MNIST, even a medical image dataset called Blood MNIST.
So a good mix of data types to really put it through its paces. I'm on the edge of my seat here. How did it perform?
In a word, exceptionally. It consistently outperformed all 9 of the state-of-the-art deep clustering methods they compared it to across all 6 datasets.
Wow, that's impressive. Are we talking minor improvements or significant leaps forward?
Significant leaps, for example, on the blood immunous dataset, RDC achieved an accuracy of 59.1%, which is a whopping 12.8% higher than the next best method.
Okay, that's not just a jump, that's a whole new level. So ditching those pseudo labels in favor of this proximity-based approach seems to have really paid off.
It really does, and the researchers didn't just stop at measuring accuracy, they also dug deeper to understand how RDC was achieving these results.
So they were looking under the hood, so to speak. What did they find?
They found that RDC was able to avoid those problems with pseudo-labels we talked about earlier, like feature drift. The AI's understanding of the data remained much more stable throughout the training process.
So instead of being pulled in all these different directions by those unreliable pseudo labels, the AI can focus on building a consistent and accurate map of the data.
Exactly. The researchers even did a study where they tried adding pseudo-labels back into the RDC method just to see what would happen.
Oh, that's interesting. So they were basically testing whether those pseudo labels could add any value even in a smaller role.
Yes, and the results were pretty surprising. Adding even a small amount of pseudo-supervision actually decreased the performance of RDC.
Wow. So it seems like those pseudo labels really were the culprit all along.
It certainly suggests that relying on those educated guesses, even in a limited way, can introduce more problems than it solves.
Okay, this is all incredibly exciting, but let's get practical for a moment. What does this mean for someone who's actually working with deep clustering? What are the potential real-world implications?
Well, this research points to a potential paradigm shift in how we approach deep clustering. If you're working with complex data, whether it's customer behavior, medical images, or anything in between, this RDC method could significantly improve the accuracy of your results.
And not just accuracy, but efficiency too, right? If we can train AI models to cluster accurately without needing those time-consuming labels,
Yeah.
it could speed up all sorts of research and development.
Absolutely. It could free up data scientists to focus on more complex and interesting problems.
Okay, my mind is racing with possibilities here. But before we get too carried away, I do have one question nagging at me.
What?
This paper focused on image datasets, but could this RDC method be applied to other types of data? Could it work with text data, or social networks, or even financial data?
That's a great question, and one the researchers themselves acknowledge as an area for further exploration. They specifically call for more research into how this proximity-level self-supervision approach could be applied to different types of data and different clustering tasks.
So it's still early days, but the potential is there. We've only just scratched the surface of what this new approach could achieve.
Exactly, and I think that's what makes this research so compelling. It opens up a whole new world of possibilities for how we can use AI to understand and navigate the complexities of data.
It's like we've been handed a new set of tools and a blank map. Who knows what amazing discoveries we'll make?
That's the beauty of research. It's a journey of exploration, and this paper has definitely charted a new and exciting course.
It sounds like we'll be revisiting this topic in the future as more research emerges. But for now, let's take a moment to reflect on what we've learned and consider what it all means. Welcome back to the Deep Dive. You've been exploring a research paper that's really shaking things up in the world of deep clustering.
It's exciting stuff.
Yeah.
Challenging conventional wisdom and offering a glimpse into the future of AI.
Exactly. So let's zoom out for a minute and consider what we've learned.
Okay.
What are the big takeaways you think will be most impactful for our listeners?
Well, first and foremost, this paper highlights the potential pitfalls of relying on those educated guesses we call pseudo-labels.
Right.
It turns out they can actually mislead the AI
Yeah.
and lead to less accurate clustering results.
So those seemingly helpful labels are actually more like roadblocks steering the AI in the wrong direction.
Precisely. And that leads us to the second key takeaway.
Okay.
This new idea of proximity-level self-supervision seems to be a much more effective and, frankly, more elegant way to train deep clustering models by focusing on the relationships between data points. We're letting the AI uncover the inherent structure of the data itself.
It's like we're giving the AI a compass and a map instead of trying to micromanage its every step.
I like that analogy.
Yeah.
And this brings us to the third takeaway. While this research is still in its early stages, the potential applications are vast.
Okay.
Imagine a world where AI can effortlessly identify patterns in any data you throw at it.
Now you're getting me really excited.
Yeah.
What kind of possibilities are we talking about here?
Think about medical diagnoses, for example.
Okay.
RDC could help doctors identify subtle patterns in medical images,
Well,
leading to earlier and more accurate diagnoses.
or In marketing, it could help businesses understand complex customer behaviors and tailor their strategies accordingly.
Exactly. The possibilities are endless. And the best part is this
Mm.
approach could dramatically speed up the research and development process
Right.
by eliminating the need for all that time-consuming manual labeling.
So we're talking about not just improving accuracy, but also efficiency and speed.
Yeah.
This could really be a game changer.
It certainly has the potential. And for our listener, I think the most important takeaway is this. Don't be afraid to question conventional wisdom. This paper shows us that there's always room for innovation and new ways of thinking, even in well-established fields.
That's a great point. So to our listener, I encourage you to stay curious, keep exploring,
Yeah.
and who knows, maybe you'll be the one to make the next big breakthrough in deep clustering.
I have no doubt we'll be seeing even more exciting developments in this area in the years to come.
Thanks for taking this deep dive with us. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible.